Nobody noticed at first. The announcements got all the attention. The ribbon cuttings. The speeches about bringing manufacturing back. Presidents standing beside hard hats and polished renderings of future chip plants that looked less like factories and more like science fiction airports. Meanwhile, in Arizona, Ohio, and New York, construction schedules kept slipping by a few months at a time. Then another few months. Then again. 7 major American semiconductor plants are delayed right now in some form, by labor shortages, equipment bottlenecks, power infrastructure problems, or simply because the economics stopped making sense at the original timeline. At almost the same moment, China opened 14 new semiconductor facilities in less than a year. That number matters less than what's already happening inside them, because this story isn't really about buildings, it's about throughput. A semiconductor fab is basically a machine for turning time into precision. Every delay compounds. Concrete arrives late, lithography tools sit idle, a chemical filtration system misses inspection, installation teams get rescheduled. One subcontractor slips, and suddenly $1 billion clean room stays empty for another quarter. These facilities operate on synchronization. Thousands of moving parts, tens of thousands honestly. And right now, China is simply moving faster. Not in every category. Not at the cutting edge of EUV lithography. That's important to say up front because the American argument here is not entirely wrong. Companies like Taiwan Semiconductor Manufacturing Company, Samsung Electronics, and Intel still dominate the most advanced nodes. China still depends heavily on foreign tooling in several critical layers of production. But the gap people think exists is no longer the gap that actually matters. Because once you move below the absolute bleeding edge, below 5 nanometers marketing headlines and geopolitical speeches, semiconductors become an industrial-scale game. Cars, appliances, power grids, drones, factory robotics, military systems, AI data centers. None of these disappear because your chip is 14 nanometers instead of 3. In some categories, mature chips matter more than advanced ones because you can actually manufacture them in volume. That's where the story gets uncomfortable. Last year, Chinese fabs increased output capacity for mature node semiconductors so aggressively that market analysts at firms like Tech Insights and SemiAnalysis started warning about a potential global oversupply cycle. Not shortage, oversupply. The same country Washington spent years trying to contain is building enough capacity to potentially crush margins across parts of the global market through sheer manufacturing scale. And the strange part is how calm Beijing has been about it. No dramatic declarations, no ideological speeches every week, mostly just provincial financing vehicles, equipment procurement, accelerated engineering programs, local tax support, and construction timelines that keep moving even when Western competitors stall. China's Ministry of Industry and Information Technology rarely talks like Silicon Valley. It talks like a freight company, which, strategically, may be smarter. There's a detail buried in a 2024 industry briefing that stayed with me. One Chinese semiconductor equipment supplier reportedly reduced installation to production transition time at a domestic fab from roughly 18 months to under 10 by embedding engineering teams directly into facility construction phases before tool delivery. That sounds technical and boring. It isn't. That's industrial compression. That's an entire system learning how to remove dead time between decisions. The United States still builds extraordinary technology, probably the best design ecosystem on Earth. NVIDIA, AMD, Apple, Qualcomm. The architecture layer remains incredibly strong. But designing chips and manufacturing them at scale are becoming two different geopolitical realities. And this is where the numbers from the opening start landing differently. Because the 7 delayed American plants are not isolated accidents. They're symptoms of a larger problem Washington still struggles to admit clearly. Modern industrial capacity cannot be rebuilt with subsidy announcements alone. The 2022 CHIPS Act allocated nearly $53 billion to boost domestic semiconductor manufacturing. Large number, important policy. Necessary probably, but money can accelerate an ecosystem only if the ecosystem still exists underneath it. China spent more than 2 decades building theirs. Quietly, chemical supply chains, technical universities, precision component firms, rare earth refining, industrial parks connected directly to ports and rail corridors, entire municipal economies organized around manufacturing density. A chip fab doesn't emerge from nowhere, It emerges from a civilization-scale support structure. And there's another layer people miss. The 14 new Chinese plants aren't just producing chips. Some are producing engineers. Because every facility creates repetition, process knowledge, mid-level managers who've solved contamination problems at 2 a.m., tool technicians who've calibrated systems hundreds of times. You don't learn industrial mastery from PowerPoint presentations. You learn it by running factories continuously. America still has elite semiconductor talent. What it increasingly lacks is manufacturing depth at population scale. Those are different things. And once you see the problem that way, a more difficult question appears underneath all the headlines about sanctions and export controls. What happens if the country trying to slow China's semiconductor rise accidentally forces China to become self-sufficient faster than expected? We'll come back to that. A few years ago, the dominant assumption in Washington was surprisingly simple. Cut China off from advanced semiconductor equipment, and the bottleneck would hold. On paper, the logic made sense. Modern chip manufacturing depends on an absurdly fragile international chain of specialization. The Dutch company ASML controls extreme ultraviolet lithography systems almost nobody else can build. American firms dominate key software layers like electronic design automation. Japan supplies critical photoresists and specialty chemicals. Taiwan perfected foundry manufacturing. South Korea mastered memory. No single country controls the entire stack. That was supposed to be China's weakness. Then the restrictions intensified after October 2022. The United States imposed sweeping export controls aimed at limiting China's access to advanced AI chips and semiconductor manufacturing equipment. The expectation was not that China would stop producing chips entirely. Even American officials knew that wasn't realistic. The expectation was slower progress, rising costs, delays large enough to preserve a technological gap for years. Instead, something more complicated happened. China adapted sideways. Not elegantly, not perfectly, but faster than many people expected. One reason is that sanctions often assume the target economy behaves like a corporation, rational, linear, sensitive to short-term losses. China behaves more like a wartime industrial state when pressured in strategic sectors. Profitability becomes secondary. Redundancy suddenly becomes acceptable. Projects that would look economically irrational in Western quarterly reporting systems continue anyway because Beijing is optimizing for resilience first, efficiency second. That distinction matters. SMIC's reported advances at the 7-nanometer level surprised a lot of observers precisely because they happened without access to the newest EUV systems. Analysts still debate yield quality and production scale, which is fair. But even partial success changed the psychological landscape. It demonstrated that technological ceilings are sometimes softer than policymakers assume. There's a habit in geopolitics where countries mistake delay for prevention. They're not the same thing. And semiconductor manufacturing has a strange characteristic. Once enough engineers understand a process pathway, progress becomes uneven but difficult to completely stop. Slower, yes. More expensive, definitely. Impossible? Usually not. A former Huawei executive said something interesting in an interview last year. Paraphrasing slightly, he argued that American restrictions forced Chinese firms to rediscover industrial discipline they had outsourced mentally to global supply chains. That's probably overstated, but not entirely wrong either. Pressure changes incentives. The irony is almost mathematical. Washington tried to freeze China's access to advanced manufacturing capability. Instead, Chinese provincial governments started funding domestic semiconductor ecosystems with even greater urgency. Universities expanded chip engineering programs. Equipment firms received state-backed financing. Local governments competed to attract fabrication clusters the way American cities once competed for steel mills or automobile plants. Some of these projects will fail, by the way. That's important context. Chinese industrial policy produces waste alongside success. Ghost projects exist. Bad investments exist. There are fabs that may never reach profitable output. But here's the thing about scale. When a country launches enough parallel efforts simultaneously, even a mediocre success rate can still produce enormous capacity growth, especially when the rest of the world is struggling to build fast. Intel's Ohio project faced timeline adjustments partly because of labor shortages and changing market conditions. Taiwan Semiconductor Manufacturing Company encountered delays in Arizona connected to skilled workforce availability and construction coordination. These are real operational problems, not media inventions. A modern fab requires astonishing specialization. Electricians certified for ultra-clean environments. Pipe fitters capable of handling highly sensitive chemical systems. Engineers trained in contamination control so strict that a microscopic particle can destroy production batches worth millions. One fabrication facility can require thousands of workers with skills most countries spent decades allowing to erode. Rebuilding that ecosystem isn't impossible, but it is slow. China understood something earlier than the West did. Semiconductor manufacturing is not just a technology industry, it's infrastructure, like railroads once were, or electricity grids. You don't optimize infrastructure for quarterly returns alone, you optimize it for national leverage. And this is where ordinary people eventually feel the consequences. Even if they never think about semiconductors at all, every major system now depends on chips. Cars, refrigerators, payment systems, medical devices, logistics networks, AI servers, military communications, agricultural machinery. During the pandemic shortage, automakers shipped vehicles without certain features because basic controller chips weren't available. Some factories literally parked unfinished cars in giant lots, waiting for components worth a few dollars each. A $40,000 machine stopped by a missing chip smaller than a fingernail. Industrial civilization is weird like that. The country controlling enough semiconductor manufacturing capacity doesn't just gain export revenue, it gains gravitational pull. Supply chains start orbiting around wherever reliability and scale exist. Suppliers relocate nearby. Talent follows investment. Universities align research priorities. Financial institutions adapt around the cluster. Manufacturing ecosystems become self-reinforcing over time. Which brings us back to those 14 new Chinese plants. Most headlines focused on how many opened. I think the more important question is what they normalize. Because once an economy gets used to building fabs continuously, not occasionally, continuously, construction itself becomes a learned capability. Timelines shorten, bureaucracies adapt. Suppliers anticipate demand before contracts are finalized. Delays still happen, but the system absorbs them differently. America can still compete here, absolutely. But the assumption that China would remain permanently stuck one generation behind is beginning to look less like analysis and more like hope. And hope has a terrible track record as industrial policy. There's another assumption buried inside this entire conversation that deserves more scrutiny. People keep talking about semiconductors as if all chips are equal. They're not. A cutting-edge AI accelerator built on a 3-nanometer process and a mature 28-nanometer industrial controller barely belong to the same economic category. Different margins, different customers, different strategic value. The problem is that public discussion collapses all of it into one scoreboard, where whoever has the smallest number wins. That's useful for headlines, less useful for understanding power. Because a surprising amount of the modern world still runs on older chips. Automobiles often rely on mature node semiconductors because reliability matters more than absolute performance. Industrial machines can stay deployed for 15 or 20 years. Power infrastructure upgrades slowly. Military procurement moves at geological speed. Even some advanced weapons systems continue using older architectures because redesigning validated hardware creates new failure risks. A 14-nanometer chip from a reliable supplier is often more valuable than a theoretical 2-nanometer chip you can't manufacture at scale. This is the reversal most people miss. The global semiconductor race may not be decided first at the technological frontier. It may be decided in the layers underneath it, and China seems increasingly aware of that. According to industry estimates, Chinese firms are on track to control a massive share of global mature node production capacity within the next few years. That doesn't automatically translate into dominance, but it changes negotiating power. If one country becomes essential to the volume layer of industrial electronics, every downstream manufacturer starts calculating risk differently. Quietly. Nobody wants to build supply chains around uncertainty. There's a historical parallel here that I think matters more than most people realize. In the 1980s, American policymakers worried intensely about Japan's rise in semiconductors. Trade tensions escalated. Domestic industries warned about dependence. Reports circulated about industrial decline. Some of those fears were exaggerated, some weren't. But one lesson survived. Once manufacturing concentration reaches critical mass, reversing it becomes brutally difficult because expertise compounds geographically. Factories train suppliers. Suppliers train workers. Workers train competitors who eventually become suppliers themselves. Industrial ecosystems behave almost biologically after a certain point. And the United States spent decades optimizing for a different model entirely. Design in California, manufacture overseas, maximize efficiency, reduce inventory, let global supply chains handle the messy physical layer. For years, that system worked extraordinarily well. Consumers got cheaper electronics. Tech firms achieved massive margins. Investors were happy, until resilience suddenly mattered again. Pandemics have a way of exposing which systems were built for efficiency and which were built for stress. The same applies to geopolitics. One former Pentagon official described semiconductors as the oil of computational power, which is slightly dramatic but directionally correct. The difference is that oil gets burned once. Chips sit inside every layer of a digital economy simultaneously. Communications, surveillance, transportation, financial systems, artificial intelligence, autonomous weapons, data centers. Control enough semiconductor production and you don't just participate in the global economy. You shape the operating conditions underneath it. That's why the numbers coming out of China are making governments nervous even outside the United States. European officials have started discussing strategic vulnerabilities more openly. India is pushing semiconductor incentives aggressively. Japan revived domestic chip initiatives that would have sounded politically unrealistic 10 years ago. Everybody suddenly remembers manufacturing matters. Funny how that happens after losing it. But here's where I think the American conversation still understates the scale of the challenge. A fab is not a software startup. You cannot compress 20 years of manufacturing culture into one funding cycle. The CHIPS Act helps. New facilities matter. Investments from companies like Micron Technology and Intel matter. Training programs matter. Still, the timeline mismatch is severe. China began treating semiconductors as a strategic survival issue years ago. The United States only fully internalized the problem after supply chains started breaking publicly. Those are different starting positions. And there's an uncomfortable demographic layer underneath this too. China graduates enormous numbers of engineers annually. Quantity doesn't automatically equal quality, obviously. Elite American engineering talent remains exceptional. But semiconductor manufacturing requires depth across the entire distribution, not just brilliance at the top. Process engineers, materials specialists, equipment technicians, industrial chemists, reliability analysts, thousands upon thousands of them. One advanced fab can consume more ultra-pure water per day than a small city. Think about the coordination implied there. Power stability, water treatment, chemical logistics, waste management, precision tooling. Semiconductor manufacturing is really a test of whether an entire industrial civilization can synchronize itself at microscopic tolerances. The chips are almost the byproduct. And this leads to the question I keep coming back to. What if the United States is still thinking about semiconductors primarily as a technology competition, while China increasingly treats them as a systems competition? Because systems competitions reward patience. They reward governments willing to tolerate inefficiency temporarily in exchange for capability later. They reward dense supply chains and manufacturing repetition. They reward societies comfortable training huge technical workforces, even when short-term profits look mediocre. The market alone rarely builds redundancy voluntarily. That's the contradiction sitting underneath all of this. America still leads in many critical semiconductor technologies. That part is real. But leadership at the frontier doesn't automatically guarantee control over industrial scale, and industrial scale has a habit of becoming political influence over time, sometimes quietly enough that people notice only after the leverage already exists. And in Beijing, I suspect that's exactly the point. Remember the detail from the opening about reducing fab transition time from 18 months to under 10? That wasn't really about efficiency. It was about tempo. The country that controls industrial tempo eventually changes the behavior of everyone connected to the system. Suppliers speed up because delays become unacceptable. Universities adapt because industry demand arrives continuously instead of cyclically. Local governments learn how to approve infrastructure faster because they've already done it 15 times before. Repetition becomes competence. Competence becomes momentum. And momentum is extremely difficult to sanction. I think this is the point where the American discussion still drifts into comforting abstractions. People say things like, the US innovates while China copies, which sounded persuasive 15 years ago and sounds increasingly outdated now. Not because China suddenly surpassed the United States across every category. It hasn't. but because manufacturing ecosystems evolve through accumulation. Skills layer on top of each other. Supply chains mature. Engineers move between firms carrying process knowledge with them. Eventually, imitation turns into iteration. Then iteration turns into competition. The semiconductor industry already contains examples of this transition happening in real time. Chinese equipment firms, once dismissed as permanently inferior, are beginning to secure larger domestic market share because local fabs are prioritizing survivability over perfection. The tools may not always match Western equivalents yet. Sometimes they don't even come close. But if they're good enough, for enough production layers, the ecosystem keeps learning anyway. That is how technological catch-up usually works historically. Slowly. Then suddenly enough to make people revise old assumptions very quickly. And there's another irony here that deserves attention. The more Washington frames semiconductors as a national security emergency, the harder it becomes for American firms to operate according to purely commercial logic. Companies want market access. Governments want strategic control. Investors want returns. Military planners want resilience. Those incentives overlap sometimes. They also collide. China has internal contradictions too, obviously. Debt pressures are real. Some local government financing behind semiconductor expansion may age badly. Certain projects exist mainly because regional officials wanted political prestige. Overcapacity could damage profitability across parts of the industry. Building 14 fabs is one thing. Running them efficiently for a decade is another. I'm not dismissing those weaknesses, but I also think Western commentary occasionally treats every Chinese inefficiency as proof the entire strategy will fail, while treating every American delay as temporary. That's not analysis. That's emotional preference disguised as forecasting. The harder truth is that both countries are entering a long industrial contest neither fully controls anymore. Because semiconductors stopped being just business, they're infrastructure now. Military leverage, diplomatic leverage, economic leverage, AI leverage. Whoever maintains enough production capacity over the next 15 years shapes more than electronics markets. They shape the operating limits of entire economies. And unlike previous industrial eras, this competition unfolds underneath almost every human activity simultaneously. That changes the stakes. A few decades ago, losing manufacturing share in one sector was painful but manageable. Lose textile production, shift into finance. Lose steel capacity, move into software. Modern semiconductors don't allow clean separation like that, because software itself eventually depends on physical compute infrastructure somewhere. Cloud computing still requires buildings full of chips. Artificial intelligence still requires massive hardware clusters. Digital economies are physical underneath the screen. Always were. This is why I think the next phase of this competition won't be decided mainly by who announces the largest subsidy package or delivers the most aggressive speech. It will be decided by which system can sustain industrial concentration without politically exhausting itself. That's a different metric. Patience matters more than headlines there. Workforce depth matters more than stock spikes. Electrical grids matter. Ports matter. Technical education matters. Mid-level engineering competence matters. The boring layers suddenly become strategic assets. History does this sometimes. It takes the invisible parts of civilization and drags them into the center of power politics. Semiconductors are doing that right now. My own view? I don't think the United States loses this race outright. American research universities remain extraordinary. Its design ecosystem is still dominant in crucial areas. Companies like NVIDIA, AMD, and Apple still sit near the center of the global computing stack. But I also don't think China remains permanently dependent in the way many policymakers assumed back in 2019 or 2020. That window is narrowing. Especially because the Chinese objective may not even require absolute technological supremacy. They may simply need enough domestic capability to make external pressure survivable. Enough mature node dominance to anchor industrial supply chains. Enough AI hardware progress to avoid strategic isolation. And looking at the trajectory right now, they may get there sooner than expected, which brings us back to those 7 delayed American plants. The delays themselves are not catastrophic. Construction setbacks happen, markets fluctuate, complex projects slip timelines. None of that alone determines the future. What matters is whether delays become normal while competitors normalize acceleration, Because once one country learns how to build industrial capacity continuously, while another keeps rediscovering how difficult manufacturing is every few years, the gap stops being about technology. It becomes about rhythm, and civilizations, like factories, eventually move at the speed of their coordination. Anyway, that's the part I think deserves more attention than another dramatic headline about sanctions. If you want to follow where this industrial contest goes next, stick around. The next few years are going to reveal whether the world's most advanced economy still remembers how to manufacture at scale, or whether China already answered that question while everyone else was still debating it.